Here's problem number 12 from section 3.3. We're asked to find the horizontal tangents, and we'll start that process by solving or finding the derivatives of both sides of this equation. Now the derivative of y with respect to x is dy dx. I'm going to break this down into its components. Dy dx, or the derivative with respect to x of x to the fourth, minus the derivative of 7x cubed plus the derivative of 2x squared plus the derivative of 15. The derivative of x to the fourth, according to the power rule, is 4x cubed. The derivative of this, well, there's a multiplier here, so I can pull the multiplier out, and so I'm just taking the derivative of x cubed. This also has a multiplier, I'll pull it out, so I'm really just taking the derivative of x squared. And the derivative of any constant is 0. 4x cubed minus 7 times, and then using the power rule, 3x squared, plus 2 times, again using the power rule, 2x to the first. And when I'm all done, I end up with 4x cubed minus 21x squared plus 4x. And that's what dy dx is equal to. Now we're asked to find where are the horizontal tangents. And the horizontal tangents occur when dy dx is equal to 0. So I might ask, well, when does 4x cubed minus 21x squared plus 4x, when does that equal to 0? Let's solve that by factoring. I'll factor out the common x, leaving me 4x squared minus 21x plus 4. And if I'm lucky, that will factor. If I'm not lucky, I'll have to use the quadratic. Let's see if it factors easily. 4 times 4 is 16. I don't think I'm going to get up to 21 anytime soon, so I'm not going to try. I'm going to not try using factoring. I'll go right to the quadratic, where I say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, or in this case, negative 21 plus or minus the square root of negative 21 squared minus 4 times 4 times 4, and that's all over 2 times 4. So 21 plus or minus the square root of 21 squared. 21 squared. 1, 21, 42, 1, 441 minus 4 times 4 times 4, which is 16 times 4, which is 64, all over 8. So I get 21 plus or minus 441 minus 64, 3. So that's going to be a 7 and a 7, 377. Square root of 377 all over 8. So where do we think the horizontal tangents occur? At 0, at 21 plus the square root of 377 over 8, and at 21 minus the square root of 377 over 8.